Hi, today we're going to be continuing talking about ionic bonding, but instead of just working with these simple ionic bonds and writing their formulas, we're going to learn how to name them. And we're also going to look at bonding with transition metals and with something called polyatomic ions. So let's go ahead and get started. So when an element has only one oxidation state, so one ionic charge, this is one of our simpler ions. And to name these ions and these ionic compounds, we first have to say the name of the cation, and second we'll name the anion. But instead of keeping it the same way, like chlorine staying chlorine, we're going to change the suffix to IDE, so chlorine becomes chloride. So let's see a couple of examples. So in our first example that's already written out for us, we've got lithium and bromine. Okay, lithium has a +1 charge. Bromine has a -1 charge when they form ions. So when we crisscross, our formula becomes LiBr. In order to name this compound, we're just going to say lithium bromide. So we change that bromine to a bromide. And that's the only difference. Okay, so let's do another one. Potassium and iodine. Potassium is a +1. Iodine's a -1. So when we crisscross our formulas, we get Ki. I don't normally want to say Ki. I will call it by its compound name, potassium iodide. So iodide, I know it sounds a little awkward, but that's just the way we got to name it, sorry. All right, then we have hydrogen and phosphorus. Hydrogen, remember, has a +1 charge when it's a cation, and phosphorus always has a -3 charge. So when we crisscross, we get H3P. So a lot of people would think, okay, I've got this down. It's going to be hydrogen phosphoride. But we have to do the does that really sound awkward or too awkward test. And phosphoride is a bit of a mouthful. So what we say instead is we call it hydrogen phosphide. So we drop that 4 section and it just turns into hydrogen phosphide. Sodium and nitrogen, when they bond together, we've got sodium is a +1, nitrogen's a -3. So Na3N. So then we have sodium nitride. Magnesium has a +2 charge. Fluorine has a -1 charge. So I'm going to crisscross and get MgF2. And so we're going to end up with magnesium fluoride. Calcium and chlorine can also bond together. So calcium has a +2 charge. Chlorine has a -1 charge. And so we're going to get CaCl2 after we crisscross or drop and swap. And we have calcium chloride. Aluminum and oxygen can bond together. So aluminum always has a +3 charge. Oxygen has a -2 charge. So when we crisscross, we get Al2O3 or aluminum oxide. Now boron and sulfur also can bond. Boron's a +3, sulfur's a -2. So we get B2S3 or boron sulfide. Now remember that the majority of ionic compounds, we call them salts. So all of these that I'm highlighting right now are our salts. If oxygen is the anion, in the case of aluminum oxide here, we call it an oxide. So it makes it a little bit easier to remember because oxide becomes part of that name. So far, we've been doing bonds with ions that only have one oxidation state. So they have that one oxidation charge. So if they're in the first family here, they all are going to form +1 ions. If they're in the third family, 3A, if we're talking about the representative elements, they're going to be a +3 charge. Now, if they form anions, you could form either a -3, a -2, or a -1. And there are a couple of cases where you form -4s, but that's going to be carbon and silicon. But what happens when our metal's a transition metal? So we've completely ignored this section in the middle. These are our transition metals down here. And it says that the charges vary. So Transition metals actually form multiple charges. So that can throw us off a little bit. But let's look at an example. So iron, we're going to talk about iron, so Fe, has two charges it can form. So here's iron here. So it can form iron plus 2 or it can form an iron plus 3. This gets really confusing when we start bonding it with other atoms or other ions because it can form two different compounds with the same element. So if we bond iron with oxygen, oxygen is always a -2. If we have this +2 iron here bonding with the -2 oxygen, then we just get FeO. But if we have a +3 iron bonding with oxygen, it would be Fe2O3. So how do we know what's bonding with what? Well, we have to do a little dissection. And the way we do this is we have to start with the formula that the compound is in. So let's step away from iron and we're going to talk about copper and chlorine bonded together. So I have CuCl2. So what we need to do is we're going to reverse crisscross to figure out the charge of the transition metal. So reverse crisscross, so this 2, remember, came from the charge of the copper. So I know it's a +2. And I know chlorine, this is a 1 here. It's the implied one, so we don't have to write it. Chlorine is there, and the second one is always going to be a minus or an anion. So we're going to do our reverse crisscross to figure out the charges of the transition metals and the anions. So we end up with copper, which has a +2 charge, and chlorine, which has a -1 charge. So we already figured that out. So now we're going to name the compound, but we have to use a Roman numeral to tell us what the charge is after the transition metal. So we'll name it copper, and chlorine will become chloride. But I have to be specific about what type of copper I have. And in this case, it's going to be copper 2. So we name this guy copper 2 chloride. So in order to be good with these names, we have to know the Roman numeral system, at least until 4. So here they are through 5. So this is 1, 2, 3, 4, and V here is 5. So if we were to do 6, it would be a V and a 1 after that. So that would equal 6 because it's adding the 5 plus the 1. In this case, since the I or the 1 is before the V, it's subtracting, so that's how you get 4 for that. All right, so let's do a little bit of practice naming our ionic compounds with transition metals. So we'll take a look, we'll do some reverse crisscross, we'll be good. Okay, so we don't have any subscripts here. That gets a little tricky. So we could either think, okay, this is a 1 and this is a 1, or we can remember that sulfur has a -2 charge, always. So sulfur is a -2 charge. And so since there are no subscripts, we know that these cancel each other out completely. So this has to be a +2. So the name of that compound is manganese 2 sulfide. All right, so let's take a look at CuCl. Well, chlorine is always a -1 charge. There's no subscript here. There's no subscript here, so it's an implied 1. In this case, the 1 is what we want to work with. So we've got a -1. We know they have to cancel out to be neutral. So copper has to be a +1 charge. So we have copper, and then in parentheses, we're going to write 1 in its Roman numeral form, and then have chloride. All right, next up, we have iron and nitrogen bonding. Now, nitrogen forms a -3. We don't have any subscripts here, so we know that they have to cancel each other out. So in this case, iron is going to be a +3. So we have iron 3 nitride. But we can also have other compounds with iron. So like we had said up here, sulfur is -2 charge. Because we don't have any subscripts, we have to figure out what iron is. Well, it's always going to cancel out, so the charges equal 0. So iron has to be a +2 in this case. So look, iron can be a +2 or a +3, just like what we looked at earlier. So we're going to write iron 2 sulfide. And so that's how you name transition metals, or compounds that have transition metals in them. There are a couple of exceptions to the transition metals having multiple charges. And these exceptions are silver, these are the ones you need to know, and zinc. So silver is always going to be a +1 charge. It does not have any other oxidation state. Zinc is also only going to have one oxidation state, even though it's a transition metal. It's always going to be a +2 charge. And we can see them line up really nicely on the periodic table, and it's going to help us to see where they are. So we have silver here, zinc here, and I'm going to highlight aluminum because that's going to help us see some stuff. Switch back over to the pen. All right, so silver has a +1 charge, so I'm going to write a 1 right there. Zinc is a +2 charge. And we know because aluminum is in that 3A family, it has a charge of +3. So they line up 1, 2, 3. And so that's how we can remember what the charges are. Aluminum is always going to be 3. It's got that 3 right above it. So if you just remember 3, 2, 1, they form a nice diagonal. You're going to do very well there. Next up that we're talking about is polyatomic ions. Now, an ion formed from just one atom is called a monatomic ion. We've been working strictly with monatomic ions throughout our ionic bonding lesson before. But ions can be formed from more than one atom, and when that happens, it's called being a polyatomic ion. There are a lot of very common polyatomic ions. Luckily, you're not going to be responsible for knowing all of them. You're going to be responsible for knowing 6 of the most common polyatomic ions. And for these ions, you're going to need to know the formula, the charge, and what the name is. So the ions that you are going to be responsible for are ammonium, nitrate, hydroxide, carbonate, sulfate, and phosphate. So I'll have a different list so you can write them down. So you're going to be in charge of OH -1. This is hydroxide. You're going to be in charge of knowing this guy here, which is nitrate, NO3, which has a -1 charge. SO4, sulfate, has a -2 charge. CO3 has a -2 charge. So this guy is sulfate. This guy is carbonate. This guy is phosphate. So PO4 with a -3 charge. And this is the only positive polyatomic ion you're going to need to know. And this is ammonium. Not ammonia, ammonium. Okay, and it has a +1 charge. And so we can remember this by saying O, no, so, co, po, no, homework for NH. And then skipping the first one, 3, 4, 3, 4, 4. And then we know 1, 1, 2, 2, 3, 1. We're going to continue working with polyatomic ions in class and in our next video. So if you have any questions, please make sure you write them down so we can talk about it when we see each other. Have a good night. Bye.